All right, so for this video, we're going to continue talking about exponential growth and decay rates, like working backwards to find the rate. But this time we're going to do it from an actual model, which is most likely what you're going to see on the EOC. So if you remember, when we did exponential rates, we multiplied it by 100, and then we would add or we would subtract 100, depending on how we reversed it. So if I go back and I look at what we did here, we take the base that is already given in the equation. We multiply that by 100. So when we multiply that by 100, for this one we got 125%. But then we subtract the 100% because initially we did 1 plus the rate that we converted when we divided it by 100. But we're not dividing by 100 anymore because we're not creating the equation, the function. We're actually trying to find the original base from the equation. So once we multiply the base and we get that percentage, we're going to subtract 100. So we did that for each one. So we took the base here was 1.095. We multiplied by 100, got this percentage, and then we subtract 100% and got what's left over, and that was the growth rate. Now we kind of do the exact same thing, but we do the switch the percentages around. So we had 2 over 5, which is 0.4. So we take 0.4, we multiply it by 100, we got 40%. So how far is that from 100? Well, instead of doing this percentage minus 100, we flip it and do 100% minus the percentage so we don't get a negative, and that gives me 60%. Same thing here, we have 0.88, we multiplied it by 100, got 88%. Well, 88%, if we flip it around and do 100 minus that, and we got 12% decay. So we're going to do this exact thing. They're going to give us a problem. So it says Guinevere deposited $400 into her bank account. The equation, and I can tell this is exponential because I got a variable in the exponent, can be calculated after the value. What is the annual interest rate? Which just means what is the yearly interest rate, which is, it says T is in years, so we're good. So we're going to take the base. So my base in this problem is 1.07. So we should be able to see that it's growth, because they may ask you if it's growth or decay. So we're going to take that base and we're going to multiply it by 100. And when we multiply it by 100, we get 107%. Now, we can't have 107%. That is not right. And we can't use the originals with the percentages like that. So why is it 7%? Well, it's 7% because we still need to subtract 100% from it. And that equals 7% growth. So again, it's growing by 7% each time. All right, so then we look at number 2. So which statement is true about the exponential model? So again, I know it's exponential because there's a variable in the exponent. So we're going to take the base. So remember, the base was going to be, depending on whether it was growth or decay, is 1 plus r, 1 minus r. You should be able to see that that is less than 1, but greater than 0, so we know it's going to be decay. Now, since it's decay, we're going to get rid of A and C because those are both growth. But a lot of students will just see this number right here, 0.85, and say, oh, the answer is B. No, the answer is not B, because we had to do 1 plus R or 1 minus R. So we're going to multiply that by 100, and we get 85%. Now, that 85%, we need to subtract, or flip it around this time, and do 100% minus 85%. And we get 15%. So just keep that in mind, that we're looking at a decay of 15%. You have to subtract that 100% either before the number or after the number to get the correct original percentage. All right, so number 3. Again, what's true about this exponential function? My base is 1.16, so we know this is going to be growth. We know it's growth because my base is greater than 1. So we can go ahead and get rid of A and C because that's decaying. So we take 1.16 and we multiply it by 100, and that gives me 116%. All right. So now to figure out what was the original percentage, we're going to take that 116% and we're going to subtract 100% from it. And that's going to give me 16% of growth that's happening in this problem. So my answer for that one is going to be D. I guess the main thing that I want to make sure, oh, no, it's not D, sorry. The main thing that I want you to pay attention to is the base right here is not the original rate. Because remember, we did 1 plus R here. So that 1 that we're subtracting away is 100%. 1 is 100% as a percentage. Okay, so just keep that in mind. All right, so for number 4, this says the function, they give me 20,000 times 0.7 and raised to x. So we know it's exponential. And it says the car is in years, okay? They want us to describe the rate of the value of the car. So they're asking for the rate. So we're going to look at the base. I should be able to see that the base is decay. And I know it's decay because I know that my base is less than 1 but greater than 0. All right, so since we know it's decay, we can go ahead and get rid of the growth problems. And then from there, I'm going to go back and find the original rate. So I'm going to say 0.87 times 100 to put it in a percentage. And that's going to give me 87%. But again, 87% is not the original rate. That's the rate of the whole base. We don't want the whole base. We want just the rate of decay that was given to us originally. So we're going to flip it around this time so we don't get a negative. And we're going to say 100% minus 7%. That leaves me left over 13%. So if they had given this original problem to us and asked us to create the equation, it would have said something about decaying by 13%. All right, so same thing here, very similar to an EOC question that I've seen previously. The enrollment at Greenwood Elementary School was 865 students. They give us the equation. So we're looking at our variable in the exponent, so we know it's exponential. And it says the number of students in is enrolled in T years. So again, we're looking for years, or the time frame is in years. And we're going to look at the base. My base is less than 1, so we know it's decay. Okay, so we know it's decay because my base is less than 1 but greater than 0. So this one says decaying, growing, decaying, growing. So let's get rid of the growth ones. Now to find the original percentage, same thing. We're going to multiply it by 100 and get the percentage. So that's 92%, but that is not correct. We have to subtract that 100% for the 1 that was in the original 1 minus R. So once we subtract that, we're left over with 8%. So we know it was decaying by 8%. So decaying by 8% is C. So hopefully you're starting to see the pattern every single time now, because I mean all of these are very similar problems that you can see. Amy deposited $2,500 into her savings account. The value of the account after T years is given by the equation. So my base is 1.018, so that's going to be growth because that's greater than 1. So we can get rid of, well, none of the answer choices because they all say that they're growing, so that's not going to be an option. So we just have to go through with the process. So 1.018, we're going to multiply that by 100. And when we multiply that by 100, we get 101.8%. Now, this is growth, so this time we're going to take that percentage and subtract 100 because it's going to be bigger. And we're going to subtract 100%. And we get 1.8% of growth. So 1.8% of growth. So 1.8% of growth is going to be B, because that's the one with 1.8. All right, so a couple more, and then hopefully you'll feel comfortable with this. So they want us to tell whether it's growth or decay. So I have my equation here. That's going to be growth because it's greater than 1. So we have 1.3%, and that base not 1.3%, 1.3, that's greater than 1. So we're going to get rid of all the decay problems, which is just one of them. So we're going to take 1.3, multiply it by 100, and when we multiply it by 100, we get 130%. So now that we have 130%, we're going to say 130. We're going to subtract 100% from that, and we have left over 30%. So we're growing by 30% given the original problem, so the answer for that one is D. And then finally, last, same situation. They give us the base. We're going to look at the base. We can see that the base is decay, very small decay. And we know it's decay because 0.06 is less than 1 but greater than 0. So we're going to take 0.06 and we're going to multiply it by 100. And that's going to give me 6%. Now we're going to say 100%. We're going to flip it around so we don't get a negative. Minus 6. And it is actually decaying by 94%. It was a very large decay there. And we could have originally gotten rid of C and B because it said increasing. Increasing means growth. Decreasing means decay. So again, multiply the base. Look at the base, tell whether it's growth or decay. Multiply the base by 100, and then you take that and you either do 100 minus that or that percentage that you got minus 100.